Hello, it's me again, Wolfram Kreis from the European Mainframe Academy. And in the next video clips, we want to present a real impressive success story from Walmart in the United States. Walmart is one of the biggest IBM mainframe customers worldwide. And Walmart adopted the mainframe in 1975. And it has always played a very important part in the IT environment of Walmart, and of course developed during this more than 40 years. And there's another YouTube video clip from Randy Frerking, distinguished engineer at Walmart, and he is interviewed by IBM and tells in this interview that Walmart processed in 2015 500 million transactions a day, and 150 million of these transactions are in between web services. So very new technology to access data and transactions on the IBM mainframe. There's a very interesting website. I don't know if you are familiar with it. It's the IBM Redbook website. Just point your browser to redbooks.ibm.com and you get a lot of information about IBM platforms. Not just mainframe, but of course also about the IBM mainframe. And why do I show this? Because Walmart contributed to some very new Redbooks, starting in 2016 with a Redbook with the title Creating IBM COS Cloud Services, followed in April 2016 with a Redbook How Walmart Became a Cloud Service Provider with IBM 6, and a third one, quite new, in February 2018, 6 and the IBM 6 and the coupling facility beyond the basics, because we talked during this MOOC about sysplex, parallel sysplex, and so on. And this Walmart infrastructure is really a very impressive implementation of such a clustering technique. These, out of a series from 12 video clips complementing the Redbooks mentioned, we show here the first with the introduction and the last with the summary. All the others, if you are interested in, you can get from this Redbook website. Let's start with the introduction.
Hi, I'm Randy Frerking, Distinguished Engineer at Walmart.
And I'm Rich Jackson, Principal Systems Engineer at Walmart.
In 2007, Walmart averaged 200 million transactions a day in CICS, primarily in 3270, MQ, and VTAM SNA access.
In 2009, we introduced web services, primarily SOAP and primarily used as a data access layer. And by 2011, we had grown to 500 million transactions a day.
In 2013, we introduced REST services and developed our first cloud services, a key value database, a caching service, and a unique ID generator. We also created a dedicated sysplex called our Cloudplex. You don't like that term, do you?
I do not like that term.
You'll get used to it. And now we average about 700 million transactions a day.
We were able to achieve this volume by leveraging coupling facility and fully utilizing parallel sysplex. Now, some of the traditional components of parallel sysplex include things like GRS, group buffer pools, or JES2 checkpoints.
Most recently, CICS has added new features to the coupling facility, such as the named counter, the coupling facility data table, shared temporary storage servers, and record level sharing.
In this video course, we'll share some things that we've done with all of these CF technologies. Thank you for watching.
And now let's show the summary.
In this video series, we have covered a number of specific CF technologies that can be used in interesting ways.
These features can be combined to build reliable, available, and highly scalable application solutions.
We'll briefly cover a couple of examples where we've taken some of these specific CF technologies and combined them into something greater.
The first example will be sequencing captured updates in real time in a fluid manner.
In our particular problem, we have an application that needs to synchronize updates from that application to another application.
Problem with that is after the data has been captured, it needs to be transformed. And during the transformation process, which does take time, the data gets out of sequence.
So the challenge is reapplying the updates to the target system, resequenced into the order that they actually occurred.
We used several CF technologies to create this solution. One of them was vSAM RLS, which we used to house shared control information.
We also used CFDT. We stored a number of things in there, such as additional control information, sequence numbers for the updates, and we also used it for caching.
We also used GRS for coordination of information between parent and child tasks,
as well as establishing control in our transaction environment by using it as a global trans class.
In our next example, we had a requirement to process a one-to-many parallel processing service.
For this particular problem, the scenario involved a single incoming request that triggered numerous parallel outbound requests to remote sources. The information from those remote sources needed to be combined, aggregated, and returned to the requester.
To create this solution, we used several CF components. One of them was using shared temporary storage for task coordination between the primary and the multiple secondary tasks.
Yes, and we also used GRS to serialize activity against those TSQs.
We also used CFDT for caching information that was retrieved from the secondary tasks provided to the primary task.
And that was very important in this case because the remote host involved in this situation were network attached devices, so there was significant latency. More examples like these, as well as additional details on everything we've talked about in this video series, are available in the Red Book. Thank you for watching.
This was the introduction to this Walmart success story. For questions and remarks concerning our video clip, please use the discussion forum on the OpenHPI platform. Thank you very much for attending, and we will see us in one of the next video clips.